looks like we have quorum here, so it's 11:32. We'll get started. I want to say good morning, everyone. Thank you for joining Rumsey and our ongoing Locked In series here being hosted by Rumsey Specialists. My name is Sean Huber. I'm one of the Automation Systems Groups managers here at Rumsey Electric. Today we're talking about the power side of our business with a presentation on VFD and how to protect your motor. So with that, I'd like to introduce Michael Lohr. Mike's been with Rumsey for just about 5 months, which he has a longer history in that, and I'll let him talk to that during his presentation. But it's been an awfully interesting couple of months here for his start. Mike primarily covers our Malvern, Delaware, and Maryland areas and is one of 3 specialists that are specific to the drives technologies. Just so everybody on the call is aware, if any of the drives guys are out on calls, any of the other ones are out and available to pick up and help out in the meantime. So you'll also see that Jared and Rick are also on this call. So with that, Mike, I will turn it over to you and let you get started.
Thanks, Sean. Hi, everyone. My name is Mike Lohr, a drive specialist with Rumsey Electric. As Sean said, I've been with us for about 5 months, but been in the field for about 35 years. And my baby steps were in the U.S. Navy on a nuclear submarine. And I'm also an avid scuba diver. During our Locked In series, we've given a number of VFD webinars. This is one of them. But if you look on the screen right now, you can see some of the items that are on YouTube that you can go to as soon as you need to. And Sean, are there going to be hot links to this when it's on YouTube or no? Is it going to be part of the subject line?
So yeah, or if you go to any of the historical webinar series, it'll take you directly to the YouTube video. So they're all fairly easy to find. And you'll get links to all of that, and you'll see that following this presentation.
With our ROCKWELL resources that we've all used in our series, these are the major resources that we use. Look at these every day. The biggest one that we're going to be probably using right now is the last 2 that you see there, the drives IN001, the drives AT003. But these will all be provided. Links to these would be provided in the follow-up email that you guys get. What are we going to be going over today? We're going to be going over how to protect your motor with the use of a VFD. To get it started, we're going to be going over some motor basics, your VFD basics. And when I say basics, I mean very basic. We've already done things on VFDs and motors in these series. We're going to go into motor overloads with the use of VFD and with a normal starter. We're going to get into some reflective wave issues that are caused because you use a VFD. The common mode currents, essentially noise that's caused with the use of a VFD, and bearing failures that are caused with the use of a VFD. Let's get into it. What is a motor? A motor is essentially, it is just a piece of equipment that takes electrical energy and creates it to rotational torque. That's all it does. It's just about as dumb a thing as you could possibly get in the electrical field, but it's the most important thing. Because 60% of all loads that are in industry right now are through a motor. So we need to find a way how to reduce, the use of these and how to reduce power. And we do that with the use of VFD. But when you have a motor and you normally start it, what you usually get is you get a very high inrush current that gets to a braking torque, and then the torque will drop, just to operational loading. And to do that, to reduce that, you use a VFD, and you essentially take your starting current and you reduce it to almost 0. But there is some bit of it. But when you see it starting a normal starter, just the motor itself will give you a 600% rise in current. And when you use overloads and turn off devices when they get overdriven, they have to have something that's going to allow you to get through this initial startup and allow you to operate the motor, because it does get up to 600 to 700% of normal starting current. And the use of a VFD is the easiest and simplest way to do that. But what is an overload? There's a couple different kind of overloads. One is a short circuit overload, which is a very short burst of electrical current that's caused by a dramatic event, usually a failure. Whether it's a failure inside the motor, it's a failure inside the conduit, it's a failure because somebody's doing some kind of maintenance, but it's usually caused by a failure of some sort. The regular overload that would cause a long overcurrent event is usually caused by something that is it's wearable, or it's age, or it's something that's not supposed to be in the system that's in the system. Usually it's something that's caused by and by other events. Usually has to do with age, but it could be any number of items that will give an overload to the motor. And that said, what causes these? You could have a mixer that will have something in it that's viscous to a point where that's the normal operating condition, and then they put something different in it. You go from pumping water to pumping something that has a slurry that's going to have more drive into it. It's going to cause an overload condition. A jam, like you see those wood chippers. You have an electrical wood chipper, and if they throw something in that's too big, and it's just going to jam it, and it's going to cause an overload. Another one is phase imbalance. It's a lot of them that people don't really go over, but if you have a system that you have three phases and you have A, B, and C, they should be equal. But if you have all your loads off of going between A and B phase, that's going to give you a load imbalance, and it's going to cause an overload also. That's something to keep in mind. Oh, wrong way. Sorry. Well, we're here to talk about what happens when you have a VFD in the system. This is a very simplistic view of a VFD. Essentially what a VFD is it takes input current, three-phase normally, and it creates a DC current. So you have AC to DC, and then it will take that DC and then it will chop it up using our IGBTs and create another AC wave that goes out to the motor. And those chopped up pieces of DC, positive and negative, are what we control with the VFD. And the VFD itself has overload protection in it. We have two versions of overloads. We have the overloads that's intrinsic to the VFD itself, which is our normal duty and heavy duty modes, which in normal duty VFDs are what some folks call variable torque, and heavy duty applications are what some folks call constant torque. But the normal torque version is for normal, like a water pump, a fan, and that will provide you 110% full load amps for up to 60 seconds before it'll trip out. It can go up to 150% of full load for 3 seconds before it'll trip out. The heavy duty ones, as you can read here, it gives you a higher loading than the normal duty will. It's 150% for 60 seconds and 180% for 3. You can also set our 200 or set the heavy duty application VFDs 200%, but you have to program that. That's not something that's just intrinsic to the VFD itself. One of the items that you have to be careful of when you are installing a VFD is a reflective wave. And this usually comes when you have a cable and a motor that aren't matched closely. And it's one of the items that when you get reflective wave, ringing of the cables, it will cause a dramatic destruction to your motor. You won't be able to use it anymore. But we're going to go over a couple ways on how to defeat it. But what causes it? Essentially, what happens is, the VFD is going to put out these pulses to make the AC sine wave. But while these pulses, they can pulse up to 3 or 4 times the regular voltage that you would see on with a normal electrical system. So if you're putting out 480 volts, you can see up to 12 to 1500 volts going into the motor. Motors don't usually like that. An old motor that's not VFD rated is definitely not going to last very long if you're going to use it with a VFD, especially one that you're going to have to control a lot of the output. And it will cause destruction to the internal windings of the motor. And if we're just going over the basics here, but if you really want to get into it and find out what happens to it, you can go to the supporting documents and the tech paper that you see on the screen here. But what happens with this is you increase voltage at the terminals that is going to cause motor damage to the insulation. And if you have a short run of cable, you're only going to see a 1 times, so if you got 480, you're going to see 480. But if you have longer runs, what happens is, because of the capacitance of the cables, it's an additive effect to the voltage, and it will double the amount of voltage that you have in it. But why is it a problem? The screen shot that you see here, that's a normal voltage on the top. On the bottom one is the 2 times voltage, which, when you're talking voltages that are in the thousands, that's when you go to up to a 2000 possibly. That's where you can get definite motor damage. And the motor damage, when it occurs, it doesn't occur in the pecker head of the motor. It occurs in the windings, and you have to rewind the motor or get a new motor. It's not something that you can just easily repair. And it almost always happens on the first winding of the motor. And another thing that it will do is, if you have a motor that isn't VFD rated and it has any voids in the insulation, the higher voltages will seek those insulation voids. But what do you want to do to mitigate these reflective wave items? You want to try to keep your motor leads as short as possible. We know sometimes that isn't possible, and we do have items to allow you to assist with that. But buying and installing inverter duty insulated motors is the best thing that you can do, instead of using a motor that is not inverter duty rated. They will not last very long unless you have something that says that they are rated for a certain voltage, and the motor manufacturer will have to give that to you. Like I said, you can see this is 40 feet is a typical VFD lead length that we'd like to see, shorter if possible. And these are the NEMA voltage classifications that Rockwell has for their VFDs. A normal non-inverted duty rated motor is 1000 volts peak. A heavy duty motor that's non-inverter duty rated is 1200 volts peak, and a inverter duty rated motor is 1488 volts peak. Now, they also have 1600, 1850, and 2000 volt peak categories, which you can purchase. And if you're going to have longer lead length motors, it's preferred that you do have these higher voltage category motors, because it will help with the reflected wave.
So, Mike, let me just jump in real quick, just as a reference. If you go back to that slide, so Mike was talking about the 1 times and 2 times bus voltage. I think he kind of referenced the 480 volt incoming to a drive. just so that everybody is aware where some of these numbers come from. A typical bus over voltage on a 480 volt input drive is about 810 volts DC. So, typically if you would go into your drive and your plant running with 480, you'll see the bus voltage, somewhere in that 650 to 750 range. So 2 times bus voltage. The reason they're showing here the 1600 volt peak category, which is what we usually shoot for a motor being manufactured for a VFD, is 2 times that is 2 times 800, 1600 volts. A lot of times where we'll see, Mike referenced the higher voltages are really long lead lengths. Like you can get into cases where you have a motor lead length for a pump that could be 10,000 feet away. But also, especially, along the Delaware, we have a lot of 575 volt input drives. And when you start having 575 volt, you'll see motors wound for that 2000 peak or 2300 volt peak category. If you don't have motors at that 575 volt input to the drive rated for that, then you definitely have to look for some of these other things that Mike will be talking about here in a second. Just to keep your motor protected. So go ahead, Mike.
Yeah, thanks, Sean. And this is from our drives IN001 document. You'll get a link to this document after the item is sent to you. Well, what this shows you that your pulse width modulation, you can change the frequency in which it is sent out. And what you see here is we have a 2 kilohertz and a 4 kilohertz signal. And you can assist the motor by, reducing the output of the carrier frequency, which is the pulse width modulation frequency. And that will help. But what that does is that, that'll decrease noise in the system. Also, we'll get into some of the noise things soon. But one of the items, the biggest items to add is add a reactor. As you can see, a reactor here, just in a normal rated motor, you go from 275 feet to 500 feet. So you almost double the length that you're allowed to use it. And if you have a reactor plus a damping resistor, you can, have it just as long as well. Here it doesn't really show the distances, but when you get into the higher horsepower models, the distances go up quite a bit. But what does a reactor do? Essentially, what it does is it reduces the curve. Everybody in today's world knows what reducing the curve is. And what this does is instead of it sending out that very high initial bump out to the motor, it flattens that bump and makes that a much smaller bump, which will reduce the destruction. And it can't be stressed enough that when a VFD sends a signal out to a motor, it's really not a very nice signal unless you can clean it. And load reactor is one of the ways to do it. Another way is a DVD-T filter. And DVD-T filters are a better way to do the same thing as a load reactor. So if you have if you have what they call a noisy system, because all the VFD is going to do is going to take, if you have noisy stuff coming in, it's going to take that noisy stuff and it's going to put noisy stuff out. And what a DVD-T filter will do is it'll take out a lot of that noisy stuff. And it'll make the sine wave going out to the motor much cleaner, so that there's not nearly as much damage that could possibly happen. If you're going to have a very long lead length, and sometimes there's no way to get around it, you have a spot where this is if in spot A is where you're going to have all your electrical rooms. But you have to go to the other side of, the campus or the factory or, the treatment facility. You have to have a very long run. And a sine wave filter is probably the best way in order to reduce reflective wave and allow you to operate normally. And these can go, up to, 15,000 feet, which, I mean, that's almost 3 miles. So you can have a very, very long lead length with a sine wave filter. They're probably the best way to have clean power. Next item that we have to discuss is common mode noise.
Let's just pause there for a second, Mike. Just give 1 second. Just remember, everybody, you are muted. I don't see anything coming in on the chat, but that is, those three devices, or those three styles of devices, are some of the most commonly used product to try and protect motors. If I had my druthers in any way, shape, or form, but of course space and heat and costs are always a part of it, I would always have a line reactor at the very least on the output of my drive, mainly because it's the first thing that ugly signal hits, and it's a big inductor, so it gets fairly hot. But it's better that thing without bearings and other moving parts and other things get hot versus your motor, just to let your motor last longer. But with that, are there any questions kind of around any of those mitigating techniques or products that are there? All right. I'll take that we answered at least them as mitigating pieces. So with that, I will let you take over, Mike, for common mode noise and some of the benefits there.
Thanks, Sean. So common mode noise and EM emissions. Essentially, common mode noise is exactly that, noise. So when you hear your VFD starts screaming, a lot of that is because of common mode. What causes it? It's caused because what you have is a switchable electronic device that's on a system, a PLC, a VFD, an encoder, and any of these items is going to give you noise. And the controlling items for these use smaller voltages. So if you're going to have a level indicator, it's probably going to have some sort of 0 to 10 volt and 4 to 20 milliamp signal that's going to go back to the VFD to allow this control. And a lot of times what you'll see is folks will take one of these control wires and they'll put it in the same conduit as a power wire, and that will introduce noise into the system. But what this will show you is you got the switching pattern of your IGBT, and you can see that a common mode voltage is going to be introduced into it because of that. And you can reduce this. You take that 4 kilohertz signal, you can reduce that to 2, and not only will that increase the amplitude, but it will also it will decrease the amplitude, and it will also decrease the frequency. And if you're looking at common mode current, really the biggest item that you need to look at is ground. So everything has to be ground together. So your motor and your drive and your earth ground all have to be to the same path. Lots of folks, when they're installing a VFD and a motor, they'll take the VFD and they'll ground it, and they'll take the motor and they'll ground it, but they'll ground it to the local, whatever the local thing, piece of steel that they can ground it to. But you have to make sure that steel that they're grounding it to is also the same piece of steel that the drive is ground to. So if it's a different piece of steel in a different building, you have to tie those two grounds together. But one of the ways to reduce it and this is your basic, almost 90% of installing contractors will install this. They will install the drive, they'll install cable, and they'll run that cable through a conduit. And what they need to remember is they got to strap that conduit to the same earth ground, because you're looking at the capacitance of the cable, because essentially a cable through a conduit it's just a big capacitor. And if there's a difference, that capacitance is going to leak. So you really need to strap that conduit to the same ground that the motor and the drive are grounded to, and that will reduce the amount of noise. And when you're doing this, remember that if you have multiple motors and multiple drives, you have to limit the amount of cables that you have in that conduit to only 3 sets. So you can't have more than 3 sets of cables per conduit. Now this is a better means of doing of connecting a VFD and a motor, is you use a shielded cable with a PVC jacket. And this essentially does it provides a better isolation path for ground, because you don't have as big a capacitive discharge with the shielded cable. But make sure, whenever you're doing this, please make sure that your motor, your drive, and all of your connection points are going to the same ground. Now, the best thing to do is when you have your drive, you have your input to your drive. That's going to be a armor cable with PVC jacket, and the output is going to be the same kind of cable. And make sure that if you have everything connected in this manner, this is the best thing that you can do to reduce common mode noise, so that you don't get that bad thing happening to your drive. And one of the items that we always recommend is use Belden cable. They're a great manufacturer. They're one of our one of the best cable providers on the planet. If you guys got any questions, please give us a call and we can help you get the right cable for your application. But if you haven't wired these things up in the manner that I discussed previously, how do you take care of common mode noise? One is you could just put a choke around around everything, and that will definitely help. That's one of the items that you can fix in place. But the best thing that you can do to take care of common mode current is grounding. Grounding. Don't know how else to tell you. You got to have proper grounding for common mode current. If you do have it, easiest thing to do is you can change the PWM frequency in the drive. That will reduce it. It does have some other risks that you can take with it, but that's one of the ways to do it. If you can use shielded cable, please do that. We also have an EMC plate that's pictured in this slide that will help you to provide good grounds. The common mode choke, and one of the better things that you can do for this is MTE, the DV Sentry filter. That will help with this also.
All right, Mike, and I was going to say, if I can just jump in on a couple of anecdotal comments.
Yes, sir.
For everybody. So, Mike has mentioned, if you want to go back one slide there, Mike, Mike mentioned about the PWM frequency, and through my history of being a drive specialist and working side by side with many of you, the PWM frequency seems to be the most overlooked quick adjustment that you can make with a drive. And one of my examples was, we were working with a customer and replaced a bunch of old drives, and most of the older drives had a standard out of the box PWM frequency of 2 kilohertz. Well, we replaced them with a bunch of power flexes, which I believe the out of the box frequency on those was 4. When the plant started to run the next Monday or whatever it was, about every 5 minutes or so, a bunch of PLC5 IO cards would all blink on and blink off, and then of course crash a bunch of things. The actual easy fix of that, beyond all of the grounding and all the things that could have been done well or different, was just literally going in and changing the frequency on the drive from 4 kilohertz down to 2 kilohertz. and basically it matched what was there historically, and whatever the electrical resonance was, disappeared, and they didn't have any problems anymore, and were able to continue to run production. So that was like a side note example of where that comes in. But I also want to point out specifically these EMC plates. Now here it's for a PowerFlex 5 series drive, but they do have them for the 7s. I recommend them whether you use the common modes or not. I mean, obviously, if you have them, you should use them. But it just even gives you a nice place for strain relief on cables that are hanging straight down, even if you don't have shielded cables. So there's a lot of benefits, and people overlook them in the catalogs and selection guides because they're listed as EMC, and people are like, well, I'm not generally trying to meet CE. So therefore, I sort of don't look at them. So there's some good benefits there, just to be aware that they're there. And then one last thing, just because the MTEDV Sentry filter is listed kind of at the bottom of this, when you're using an output device, make sure to look at that manufacturer's output device user manual, because there are times when a particular manufacturer will tell you to raise or lower the PWM frequency to use that output device correctly. And it's kind of across the board, but you just want to make sure that you're also following that so that you get the best protection for your motor that you could possibly get. If you have the PWM incorrect, sometimes you can either damage the output filter depending on which one it's used, or you can make them run hotter than they need to. So just a couple of side notes and anecdotals that I just wanted to throw in there for you, Mike, just from experiences that we've run into over time.
Appreciate it. Thanks, Sean. So bearing failure. This is overlooked as how to protect your motor with the VFD. You don't really say, oh, it's just bearing failure. How does the VFD help me with that? Well, it's not the VFD that's the visible cause. What people look at, they're like, oh, there must be something wrong with my load on my motor, that's causing the bearing failure. Unfortunately, what happens is because of a lot of when you got the common mode items that you got to worry about, it goes back to grounding. But you can see that there are any number of ways that a bearing can fail and a bearing can get damaged. Because a motor is it's a current device, and it's made out of all metal, and when you create a current that causes a field, it doesn't matter which metal it is, it's going to cut through that metal. And anytime you have a magnetic field cutting steel, it's going to cause current. And what that current will do is it will go from the rotor to the stator, and the only way that it can really get there is through the bearing. And while it can handle some of it, if it gets to too high a point, you get damage to the bearing. It's caused by pitting, but because it rotates, that pit is going to be seen as some sort of a scuff. It's going to be fluted. It's going to be there are any number of different ways that it can fail. But the biggest thing that you need to look at is is it grounded properly, and is the VFD causing it, or is it a mechanical failure? Unfortunately, it's mechanical failure that's being caused by something else. And this is a small direction of current. What happens when you have a magnetically induced voltage from your drive end to your non-drive end? And it'll just go through the bearing and through the rotor and through the stator and through the bearing and through the rotor and through the stator, and it'll keep doing that, and it's just a constant loop. But one of the things that you can use to get rid of this is just to put a brush. I believe the Aegis folks make a brush that you can put on the actual rotor to discharge that current that's on the rotor to ground. You also get backfeed current. This is There's another thing of common mode current. It's related, and it's what happens when your load may be grounded, but your motor's not grounded properly. So what's going to happen? It's going to go through your motor, and it's going to go into your load, and it's going to go out your load, and then your load bearings are going to get damaged, and that's not really what you want to happen. And we'll show some pictures of this is an encoder bearing. This is another bearing that they had pictures of. That this was definitely caused by currents because of VFD. One of the ways that you can fix this is by using insulated bearings or ceramic bearings, and that will allow you to essentially reduce, if not just stop, the flow of current through the rotor. Again, we have the brushes. Again, you can see the brush items that we have on the side here that will show you, yes, it definitely helps. How do you prevent it? The best way to prevent it is to make sure everything's grounded properly. The biggest item that you can take out of this whole thing is, grounding. Everything comes down to grounding when it comes to using a VFD with a rotational motor. But one of the, we've gone over, what to do with it. Good grounding is one of the better ways to do it. If you don't have the best grounding, use a ground brush. Using insulated bearings on the drive end and the non-drive end. It's something that you can do in the field. Make sure you use, non-conductive or conductive bearing grease. And if you can install an electrostatic shielded motor, you could do that. That will also help with bearing damage.
And a couple of side notes for that, the brush, a lot of times you'll see the name in the industry of like an Aegis ring. There's other ones that are out there, but that's the one that we see most often. Couple of tidbits for the installation there is they have like little carbon fiber brushes on them, in the circumference of your output. So you'll see a lot of times where a customer or a motor will come and it'll have an insulated bearing on the non-shaft side, and then they'll put an Aegis ring on the shaft side. There should be like a silver metallic grease that also goes around that as part of the PM to also help aid in getting rid of any of the currents and stuff through your motor. So just as a kind of a side note piece that you should see out there if somebody's installing one of them on your motor, or you have them with them installed, just be aware that there should be a conductive grease as part of that installation.
Thanks, Sean. And reducing bearing damage. A lot of the items that come along with using a VFD, in order to reduce them, a lot of the items to reduce them are very similar to in all of these items. Using a line reactor, anytime you can take the output of a VFD and you can make that output a cleaner output, is going to reduce any damage that's caused by the VFD. A common mode choke filter, we discussed that one earlier. An output sine wave, another one we discussed earlier. Sean discussed it before. Changing the pulse width modulation frequency. Anything that but the issue that you're going to have when you're going to add chokes and reactors and sine wave filters is you may not have the footprint to be able to put these things in. Depending on the size of the drive, these things get very large. So it's something you have to take into account. Using a special motor that has insulated or ceramic bearings, that's probably the easiest way if you have a very reduced footprint to help with that. And ground rings, like Sean just discussed. Unfortunately, if you have a ground ring, it is going to require extra maintenance to take care of, and you got to make sure the grease properly. You got to make sure that there's actually still a a ground ring there, or at least a ground ring brush, because they do have to be replaced. But in summary, essentially when you have a motor that's being affected with a VFD, you're going to want to make sure that you look at the installation manual to ensure that it is installed correctly per the manufacturer's recommendations. And installing a load reactor is probably the cheapest, most effective way to help you with any issue that you're going to have with the output of a VFD. If you're going to have a very long lead length, use a sine wave filter. Like you said, if you have a very long lead length, sine wave filter will allow you, a 3-mile cable run, and good grounding. Good grounding, good grounding, good grounding. I can't say good grounding enough. That's probably the number one cause of issues of drive in a motor is grounding. And proper VFD cabling. You shouldn't be using THHN. Do not use THHN to install a VFD. And I think that's all I got. These are some of our Rumsey partners. They can help you with anything that you need when it comes to filtering and line mode chokes and things along those lines. And that's all I got, folks. Thank you for coming.
All right, thanks, Mike. Well, we'll open it up. Any questions that anyone has? Let's see. Here we go. I think we just had one come in. So one of the questions that just came in here: what is an issue when using both input and output line reactors? What things need to be checked?
Well, when you say issue, what are you trying to meet? Are you just trying to get rid of noise, or are you trying to meet a IEEE 519 harmonics? We didn't really get into harmonics because this was more of a motor presentation. But if you're going to look at an input load reactor or a line reactor, I'm sorry, you can use them in conjunction. And what that's going to allow you to do is, if you got clean power coming in, you're going to have clean power going out. And the load reactor is going to allow you to, have a longer lead length to that motor if you're limited on where you can put your power gear.
Yeah, I mean, I guess my answer goes right along with yours there, Mike. Is there's really not a downside to using both of them. In fact, if I had a plant and had to keep everything running, I would do my best to have both input and output, or at least some kind of a protection device on both sides. However, you do lose a little bit due to inefficiency, right? Any inductance you put out there, you will have some voltage drop. So if you already have low voltage, that could be some part of an issue. And then heat build up in a cabinet, right? If these things are in an electrical room and that electrical room already gets very hot, then you have all of these things and all these devices out in the motor or in the electrical room. You might have to worry about additional cooling and some other pieces there. But ultimately, they will allow the asset to last longer by having both of them there.
Great.
All right. Any other questions? Okay. Well, with that, Mike has his contact information up there, or if you deal with one of the other specialists, feel free to reach out to him. I appreciate everybody taking the time to tune in today. We will follow up with an email with a recording of this, as well as all links to all the documentation that we have there. If you're not sure which solution to go with, that is where the Rumsey Specialist team can help you out, give you the pros and cons, because like everything in engineering, there's usually a give and take between all of the options and all of the manufacturers that we had put up there. So with that, we will be continuing to host these presentations. We have one more on Thursday and ending out in May. And then going into June, we'll continue these things once a week. Hopefully for the next few months, just to hit different topics. So feel free to tune in. Any questions, let us know. And I appreciate everybody taking the time. Thank you.